Hello, I'm Gabriel Myers,
I'm Rocket Corey.
Hello, my name is Krishni Raj.
I'm Ethan Pimentel.
and this is our project building Tastrome Safety Guard.
The main problem that we're addressing with this project is that generative AI systems can produce outputs that appear valid on the surface, but are actually incorrect or inconsistent when you look more closely. In our case, we're working with structured food data generated by AI pipelines. These pipelines can output dish level records that may be missing required fields, contain invalid classifications, or have inconsistencies between related attributes. For example, a dish might be labeled as allergen free, but still contain ingredients that contradict that claim, or it might be missing key fields entirely. These kind of issues are not always obvious at first, and they can accumulate as data moves through the system. This becomes especially critical in food systems where strict validation is required. Unlike some other domains, errors here can translate directly into real-world consequences, particularly when it comes to allergen information or incomplete nutritional data. The key takeaway is that AI-generated data cannot be treated as inherently reliable. Without a validation layer, these errors can propagate into production systems where they become much harder to detect and correct. And so this is the gap that this project is designed to take care of.
SafetyGuard is built to take structured dish data and verify that it is complete, consistent, and safe before it moves forward. The core idea is that AI pipeline generated data should not be trusted automatically, especially when allergens or required fields are involved. Our system gives that data a clear validation process so unsafe or incomplete records can be caught, reviewed, and corrected.
We transitioned from a broad schema and theoretical rule set to a condensed schema enforcing strict but limited set of rules. We also shifted UI implementation away from the student team and was handed off to our mentor. This allowed the team to focus strictly on a robust backend API endpoints. We also dropped stretch goals like statistical anomaly detection to ensure a stable, well-tested, deterministic pipeline by the May deadline.
Our system is made up of three main parts: a React frontend, a fast API backend, and a PostgreSQL database. The React frontend handles the user-facing side of the system by allowing the user to interact with the validation results after a batch is processed. It includes a record review page and also supports pagination so larger batches are easier to review. This page also allows a user to reject the individual records, complete the review process, and navigate to the batch history page. Our Fast API backend handles all the validation logic by processing uploaded records, checking them against the required rules, and sending the results back to the front end. Lastly, our PostgreSQL database stores and supports the rule enforcement we have and helps keep our validation requirements organized and consistent throughout the whole system.
On the backend, we used FastAPI to expose the main services that power the validation workflow. These endpoints cover basic system health, rule management, validation, and metrics. The focus here was to make the backend easy to test and inspect through the Swagger documentation UI, so anyone on the team can quickly see what the API supports and confirm that each part is working. This second set of endpoints shows the workflow side of the backend. These routes support moving records through staging, review, approval, rejection, and promotion. In other words, the API is not just checking records once, it also supports the full lifecycle of what happens after validation, including manual review and moving clean data into the final canonical dataset.
We process dish data through three distinct stages to guarantee accuracy and consistency. First is staging, which holds the raw AI data. The second is validation, where rules and validation run results are stored. The third is canonical, which holds the clean final data. Two design decisions that kept this pipeline reliable were strict rule-based validation, which ensured the data was correct, and a controlled vocabulary table standardizes the key attributes.
One of the most important parts of the system is the validation stage and how we enforce data integrity through rules. To enforce data integrity, our system uses a structured rule-based approach. All validation rules are stored directly in our database, which allows us to centralize validation logic and manage it consistently across the pipeline. It also makes the system much more flexible since rules can be updated without modifying the core application code. These rules enforce several key constraints. Firstly, we ensure that all required fields are present and properly formatted, so incomplete records don't move forward. Secondly, we enforce allergen-related constraints. This is especially important because incorrect allergen information can lead to real safety risks. And finally, we validate logical consistency across fields. For example, if a dish contains wheat, we ensure the gluten flag is consistent. We also strictly validate Boolean fields and enforce safe patterns for canonical identifiers. Because these rules live in the database, we can update them through Alembic migrations. This allows us to evolve validation logic over time as requirements change. Overall, this approach allows us to systematically identify and block invalid data before it reaches downstream systems, ensuring that only clean, reliable records are promoted forward.
What makes the safety guard robust is that it adds a reliable checkpoint between AI pipeline generated dish data and the final dataset. Instead of letting invalid records pass through, the system blocks unsafe outputs, keeps data formats consistent, and gives reviewers a clear path to inspect problems. Because the process is auditable, we can trace what was checked, what failed, and how records were handled. After validation runs, the system gives a clear pass or fail result for each record. Invalid data is flagged automatically, and the summary helps reviewers quickly understand what needs attention. This is important because only records that pass the checks should continue forward, while problematic records can be reviewed instead of silently entering the clean dataset.
AI output is generative and cannot guarantee correctness. An AI model doesn't know if a dish is missing an allergen field or has ingredients that doesn't make sense. A deterministic validation layer is what fixes that, and that's why Safety Guard was built. When AI is making important decisions, responsible usage means having a system that enforces correctness, not one that hopes for it. Dish records is just where we started. The same pattern could be applied anywhere AI generates structured output. For example, in medical, legal, and financial fields, the problem is the same, and so is the solution.
We would like to acknowledge the mentors and faculty who supported this project. Thank you to Omar Rodriguez, the CEO of Tasteroam, and Gowri, our lead software engineer throughout this project, for providing guidance, feedback, and industry perspective throughout our development. And we'd also like to thank the faculty, CSUMB, Professor Page, and Dr. Su for their support and for helping guide the project towards a complete product.
Thank you.